Discord also started. Let's go. So yeah, Raj. A. In A, basically you're given presents. You Kinich unboxes two presents if they're equal, adds to that score, and then removes them from the selection. So you choose a different pair of I, comma j. Now in the question, you need to get the maximum score after performing the operations. So basically what is happening is you select two equal ones and then remove it from the array, right? So at the end of the day, your let's say I have five twos, four threes. Okay, what can I get the score as? I'll basically do divide by 2 and divide by 2 floor. You get 2, you get 2, and your final answer is 4. Why is that? Firstly, they are independent. Like since equal only I care about, they are independent. 2 का I can solve अलग से, 3 का I can solve अलग से. Now, since I can pair only different pairs of twos, I can choose the same number once again. You divide by 2 floor. Yes. So I divide by 2 and floor it because the last one I won't pair it with anything and I won't get an additional score. So that's just it. I'll share the code twice. I get the frequency array, frequency like I do a hash map frequency and then just do floor by 2. Floor by 2 is in C++ is just divide by 2. You don't need to do anything else. Like you don't have need to do a floor function. But yeah, that is it, and you get the answer. And that is it. Any doubts? Cool. Let's move on to B. B, you're given like there is an n comma m, and there are values n into m values in each like values. Okay, but the input stream there was an issue, and the integers are shuffled. Basically, if two comma input was like this. Okay, let's say one. Okay, this was the input. You flatten it out, so you get like this. This was the original input, and then you shuffled it up. Shuffle it up meaning there was some. So let's say I shuffle these two around, and I get one, one, two, three. Okay, some random shuffle, and I get this. So this is the input we get. Okay, we need to decode it and get the n comma m. Here it is 2 comma 3. 3 comma 2 also work. I can print anything here, like this or this, both work. Since in the question it is given, if multiple possible answers, output any. Okay. Now, first thing to notice is how many total numbers are there. Total numbers are n into m minus 2, plus 2. Correct. This is equal to what is it given as k. Okay. The second observation is now let's say I can have any pair of n comma m, right? But I know n into m is equal to k minus 2. What I will do is I'll look at the factors of k minus 2. Okay, in the factors of k minus 2, if I find both n comma m in my input stream, that means I can print that. If I don't find, then I print no. Like if I don't find at all, I print no. So that is it. To get the factors of k minus 2, there is a very efficient, like a very straightforward algorithm which works in root n time. You cannot do O of n. O of n means you just iterate for all numbers 1 to n. You can't do that because the problem is your values can be 10 raised to 5, and same thing for each one you're doing 10 raised to 5 into 10 raised to 5. So you might get tail. Actually, you won't, because the sum of all tests actually doesn't matter. So O of n also solution works, but there's a good algorithm which works in root n, so just try to do it in root n always. That is what I would suggest. And let's just come to the code. There is one caveat, one edge case, which I'll talk about when I'm coming to the code. Okay. First thing, I take the input, I store it in a map. Why am I storing in a map? I'll talk about that. Why am I storing it in a set? Why I'm not storing in a set? I'll talk about that later. So firstly, what is my required desired multiplication? It is here it is k minus 2. I am taking it as n, so n minus 2. Now the algorithm for getting factors in root n time, you just iterate from 1 to root multiplication, because one observation, let's say I want to get factors of 8, I get 1, 8, 2, 4, and that's it. So what is happening is if I just calculate this, these numbers are just 8 by 1, and this number is just 8 by 2. So that's why you just have to iterate till root n. So that is the root n algorithm. If it is divisible, if my current index like divisor is divisible, so first I'll check if both the factors are present in my map. Cool. If they're present, I just print I comma the two factors. Okay. Now only edge cases when both the factors are equal, I need to make sure that there are two numbers present in my map, or else I don't print it. So that is the only edge case. Basically, the edge cases, let's say it was 9, like total number of terms is 9. Let's say 1, 1, 1, 1, 4, 5, 6, 7, 8, and 9. Let's say this was the input. Wait, 1, 1. So you have k equals 11. Your n into m equals 9. Yes. So n into m equals 9. Here, if you remove this part of code, it will print 3 comma 3. But the problem is 3 comma 3 doesn't exist in the input. Like there are no two values of 3. So that is the only edge case. That is where people might have gotten a WA. But any doubts here? Yes, no. Okay, for A, simple thing you can do is, like if you don't know a lot of complex stuff, count array is the same as map. But what you also can do is, you can, let's say, uh, count array because the input is 20. So what I can do is make an array of 20, 0, 1, 2, 3 to 20. And let's say my A of I is 2. Let's say I have 1, 2, 1. So my count array will have 2 and 1. Now I just iterate everywhere else, it's a 0. Now I'll just iterate and I divide by 2. Like my answer plus equals I by 2. That is it. And if you want to do literal brute force will also work. You just choose two numbers and just remove them from the array. But yeah, because the sizes are very small, but try to do the most optimal solution because later when you're solving questions, these constraints are not always there. So then let's move on to C. C, you have to generate a permutation such that pi plus 1 is a composite number. A very good observation is if this term is even, you know it is a composite number. Okay. Why is it true? Since only even non-composite number is 2, and since you're taking two numbers ka sum and 0 is not present in the permutation, so any even number will be composite because then 2 will divide that number. Okay. Now, when is a sum of two numbers even? When it is odd plus odd or even plus even. Only case now you need to see of is, so now what I can do is just have a lot of like a set of odds here, then set of evens here. So I know these values will satisfy. These value will also satisfy. Only thing is this value will not, I don't know if it will satisfy or not. So for this, what is the first composite odd number? And that is 9. How do I get that? What are the odd numbers? 1, 3, 5, 7, 9. 1 is not, 3 is all 3 is a prime, 5 is a prime, 7 is a prime, 9 is. So that's it. Now, how do I make 9? Let's just take like I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How can I make 9 with the least number of terms? 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 4 is 7, 4 plus 5 is 9. This is 9, no? So I need this. So I just put 5 here, 4 here, all the other odds here, all the other evens here. That is the entire code. Now it just comes to implementation part. And implementation for this is, firstly, if it is 1, I just print out 1. Fair. If it is less than 5, now yeah, why do I need this 5? Like since like let's say I have 2, okay. I'll always have an odd plus even term in any size of array except for 1. Since the first odd plus even ka sum is 9 and I can achieve by only 4 plus 5, I need to have both 4 and 5 in my array. To have 4 and 5 in my array, my size should be greater than equal to 5. So all the sizes less than 5 not equal to 1 should be minus 1. And for all the others, what I do is first, first I'll just add all the odd numbers while my j less than equal to n, I do j plus equal to 2 and I plus plus. I just assign the value of j. So these are all odd terms satisfied. Now after all odd terms are done, 1 is at index 0, 3 is at index 1. 5 is at index 2. Since 5 is at index 2, I need to swap it here, right? I need to put a 5 here. So I swap it with the last number I've put in. Since I'm doing I plus plus, the last number is I minus 1. So I just swap it. Now from my beginning, the first even number is first, which is current I. I do the same code for even numbers. Then now I swap first and first plus 1. Why am I doing that? Same thing. 2 is at index first. 4 is at index first plus 1. I'm just swapping 4 and 2. I'm just printing the array. Any doubts? Yes, no.
Hey, can you hear me? Hello.
Yeah, yeah, I can hear.
Uh, okay, so I just want to say that your solution is very nice actually, but can't we just print all the odd numbers, then we print 5 and 4, and then print all the even numbers? Won't that also be a...
I did the same thing.
Yeah, yeah, you can do the same thing, but now then you'll have to add a check here that if j equals 5, continue. It just works. Whatever you want to do,
Yeah, yeah,
it'll work.
right.
Fair. And same thing here also, you'll have to put j equals 4. But yeah, doesn't really matter. Now let's come to D. In D, you're given like the problem statement is very big. So if you don't understand a problem statement like this, try to read it in parts. That is the only tip I can give you. Usually, the longer the problem statement, the easier the question is. It's just how to read the question is the more difficult part. But this is a medium level, this is a good level question with a longer problem statement. So, yeah. Now, in the question you're given, let's say I have 0 to n. Okay. I do some jumps. Okay. I can do any jump, and that jump depends on my power. Like if I have a power of k, I can go to any position between this range, x and x plus k. Only problem is there are some hurdles over here. So if I am here, I can't jump anywhere over here. I have to jump somewhere ahead. Okay, same thing if I am here, I have to jump somewhere ahead. I can jump here, but I can't jump over here. And you're given these LR ranges, let's say 1, 3, 2, 10, sorry, 5, 10, 15, 16. So you're given these ranges. It's in sorted order. There's no overlap. Everything is mentioned over here. Like it is going to be sorted order. There is no overlapping. So that is a very good thing. If there were overlapping, you'll have to merge specific hurdles. So that is a different code. There's a different logic. Since there is no need to merging and it's already sorted, well and good. Now you're given, let's say there are power ups here, 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 and here. This power up gives me some power. This power up gives me some power. This power up, let's say 1, 2, 3, and 4. I am starting with power 1. Okay. The question is telling me what is the minimum number of power ups should I use to reach this n? Okay. Now, how do we solve this? First observation, let's say if it was 0 to n, there are 10 power ups over here. Do I need to use any power ups? And there are no hurdles. Since there are no hurdles, I don't need to use any power ups. So the intuition comes, I would like to use the minimum, like if I am in a hurdle, my power should be at least this much, like whatever range it is. Let's say the range is L comma R. My power should be greater than equal to R minus L plus 1. Why is this? Because if I am here, I can't have this R minus L power only, no? And this is the maximum I can go over here, up to here. After that, I jump. So till then, I just do one jump, single jumps. When I reach, let's say this was 2. When I reach a 1, then only I'll make a jump. I'll try to make a jump. And since I can't go to 2 and 3, I can't go to two numbers. I have to jump till 3, right? So my power should be this. So this is one equation I need to satisfy always. Now, since I need to satisfy this equation, let's say I have a set of power-ups, okay, before me, and now I'm at a hurdle which which my current power cannot jump on. Let's say my power is up to here only, and I can't jump up to here. So I need to use some power-ups, some of these power-ups. Let's say this was 10, this was 1, this was 2, this was 5. I would rather use 10 than use a 1, right? Because this is the maximum power I can gain with using one power up. I need to minimize the number of power ups. Correct? Yes, no? Hello.
Yes, yes, yes.
Yeah.
Proceed.
Huh. So yes. So that is why, and after I choose a 10, let's say I'm still requiring some power, I'll choose a 5 here. Then I'll choose a 2. So what is happening over here is I am removing these numbers in order. Correct? And since I'm removing these numbers in order with the maximum power first, this basically, and how do I know what is the highest power in this range? This I do using a priority queue. There are two ways to do this. Priority queue or a sorted map slash multiset. Okay. These are the only two ways to do it. Any other way will give you TLE slash issues, whatever. And just for your information, Python map is not sorted. So here you can't do not Python map. Okay. So if anyone was had a doubt over here, I didn't know for a long time about this when I was using Python, but yeah, Python default map is not sorted. So yeah, priority queue and these these data structures, you don't really need to know them specifically what happens internally, but is just if you see over here, priority queue is just a one-liner thing. It's a data type in STL, C++. So you just declare it like an integer. You don't really need to do much. So that is very good. Actually, this is also not. Yeah. So priority queue basically tells me what is the maximum number in my particular range of sets, whatever. Okay. Now coming to the main algorithm. Now what I do is, if I'm at a hurdle, okay, all the power-ups before me, I just put them in my priority queue. Okay. All the power-up before me from a hurdle. Then I do this check. I just come to the code so you'll understand sort of better. Firstly, I'll take the input hurdles and power-ups. Now I'll have a power-up index. I'll have my current power and I'll have my answer, which is the number of power-ups used. So this is a priority queue. This might seem a bit complicated, but this basically is a like another word for it is a max heap. Okay. And this you can do in Python using heapify, if I'm not wrong. Heapify. And Python heapify, one more thing, it is min heap by default. So you need to do it minus a of I. You need to push values like this so that it becomes a min heap like by default. Now let's just remove this comment. Let's debugging. Now see, for all the hurdles L to R, now firstly I'll check if my power is lesser than this range, okay? It is my required power and my current power. I'll just do this. Right? Required power equals R minus L plus 1. Okay. Now for all the power-ups, while it is less than M, and my power-ups index ka index, okay, power-ups has two values, X comma V. X is 0, V is first. So the zeroth value, which is the X position of it, is less than my current left value. This basically means all the power-ups which are, let's say it is like this is a hurdle. I'll choose all these power-ups. I'll iterate over it and I'll push it in my priority queue. Now, while my priority queue is not empty and my power is lesser, I keep adding the topmost element and I remove it from the priority queue. Obviously, I'll also add it to the answer. Now, once I finish this loop, when do I come out of this loop? Either power greater than equal to required or PQ is empty. Say if PQ is empty, that means I don't have any power-ups left. That means it is a -1. I can't jump over this hurdle only. So you basically get the answer as -1 and you just break out of the loop. And that's it. You just let this loop do the magic and you print the answer. Any doubts?
Actually, I also use the same logic, but I am getting a wrong answer on second test case. Can you check my code?
Wait. D, your ID is Sam with DLH.
Yes,
What is this flag, sir?
Antarctica.
Nice. Huh. Ah, your problem is this is a priority queue initializes with minimum value, I think.
No, it's a maximum.
Oh, maximum only. Okay. I always get confused for this. But what you're doing is while hurdle is not empty, what are your hurdles? Hurdles are a queue. Okay, fair enough. Current is what?
Uh, I'm iterating for each point on the
Power.
number line.
Oh, you're iterating for each point. Wait. Firstly, you can't iterate over each point. The problem is, yeah, why I was doing on the LR ranges. Yeah, thank you for reminding me.
Did
Why?
you combine the LR ranges, Jenil?
Huh? No, no, you
Yes,
don't need to combine.
Acha. What I did was combine, then
No, no.
sort, then again sort, then priority queue.
I don't know, but the thing is, it is given in the input. No overlap and already sorted.
Oh, अच्छा मैंने पढ़ा इन द क्वेश्चन आई
That's why
वेस्टेड
you
लाइक
read.
30 minutes
Huh.
on that.
And the thing is here, your L can be 1e9, no? So let's say my starting hurdle only it starts at 1e8. Okay, there's only one hurdle, and my entire point L is at 1e9. So what you'll end up doing is just iterating over this entire range, and like 1e9 you can't iterate over. Like it is greater than or equal to 1e8. So that is a very big issue. Like there might be some other like bugs in your code, which I'll come to that
I
later.
think that
But
uh,
it'll give TLE
okay,
for sure.
I think I figured it out.
Yeah, it'll give TLE for sure. If you figure out the bug, it'll give TLE. So that is why you just don't do that and you do this. Um,
But like I am breaking out of it when the hurdles, like there are no hurdles left.
yeah,
So I
but
am
the thing is, if your hurdles is only at the end, no, the thing is, wait, you can do only 1e8 operations in a second. Let's say your final
okay.
hurdle is at 5e8. What will you do? Does it make sense? You'll
Yes,
loop
yes.
till 5e8. That is the issue. Now coming to E, huh. E is a very good interactive problem. If you have not read about it, interactive problem, just go about it. But yeah, E in general, I'll just do it. What is it, and I'll just do the working. Now, firstly, the function L comma R. What does it state? Let's say I have a string 0 1 0 0 0 1 1 1 0 0 1 1. Okay, this is my string. Let's say my L comma R is this range. Is this range? Okay. What it is saying is my function is basically number of subsequence of value 0 and 1, like 0 comma 1 subsequence. So what it says is subsequences I'll remove, let's say this, and I'll end up with a 0 1. Okay. Subsequences is basically I just delete numbers, and it is saying two subsequence are different if the resulting subsequence comes like different positions, like you're deleting from different positions. So this is a different subsequence from this. Since here you're keeping this and here you're keeping this. Okay. So now let's just zoom on to this like a smaller example of let's say only this 0 1 double triple 0 1. Okay. To make subsequences, I need to make subsequences of two sides, right? So if I want to have this one, include this one, okay, what do I need? 0 and a 1, right? If I want this one, how many zeros are there before? I just need to count that, right? Yes, no. To get the number of subsequences, including this index ka 1. Fair, yes, no.
Yes.
Yep. So how many zeros are there before it? Only one. So I do plus 1 here. Fair. Now for this, I need to do the same thing. I'm fixing this one. How many zeros are there before? There are 4 zeros. So I do plus 4. Same thing for this, plus 4. So what do I get? My answer is 9. Does it make sense? So this is my f of this particular string. Fair enough? Yes, no.
Yes.
Cool. Now coming to the interactive part of the problem. You need to choose these LR, and the computer will give you the output for that specific L command. Now, after the computer gives the output for L comma R, you just need to keep on querying till you know for sure this is the string. Once you know this is the string, you print that answer. And yeah, there are some constraints. Oh, the number of queries is not given.
N na size of the binary string.
Where?
ऊपर
Huh,
दिया है n questions.
huh. If your query makes more than n queries, your program will immediately terminate and will give wrong answer. You need to give no more than n questions. Yeah, correct. Yeah. No more than n questions. So how do I do this? So the main observation comes from this entire pattern. Like how I calculated for this string, I did +1, +4, and +4, right? For 0, it is what? A +0. Fair? So if I'm querying like this, let's say, if I query this, well, let's say these two, I get a 1. Okay, wait. If I query this, what will I get? 0. I'm just assuming I'll put a 0 here. There is one edge case, but I'll come on to that later. Okay. This gives me a 1. Let's say I have an answer array. What I do is I just keep on querying this, then this, then this, then this, then this, then this. Basically, just keep doing this till I reach the end. So I'll know for sure कि n queries in only I'll make. And to see if it is a 1, what I'll do is I'll store a previous answer. Here my answer is 0. Okay. When I'm querying this, my answer changes. I get a 1, right? Since my previous prev not equal to current, what I'll do is I'll put a 1 here. Okay. Same thing. Now I'll query this. What will I get? 1 only 1 once again. Since my prev is 1 now, I did basically a +0, right? A +0 is what? A 0. Same thing goes for all these zeros. And now when I query this, I get a change in value. So I add a 1. I get a change in value. I add a 1. Get a change in value. I add a 1. And so on. This code just writes itself on its own. Only thing is this starting part. Why am I saying that? Let's say it's 101 and 001. How will I differentiate? This will give me a 0. This will give me a 0. This will like querying this will give me a +0. Querying this will give me a 0. And querying this will give me a 2. For this also, querying this will give me a 0. This will give me a 0. But this will give me a 1. Okay. So what it means is till my first change, I can have a lot of ones here and a lot of zeros here. My first change will happen after the first one after a 0. Okay. That is where the change happens. Fair? Yes, no?
Yes.
Because all these ones ke pehle there is no 0. So whatever I get the answer, the first answer, this will be 4. So all these numbers like this index to 4 behind, all of these has to be 0 and all the others have to be 1. Does it make sense? Yes, no.
Yes.
Here it is 2. That means there are two zeros behind it. Here it's a 1. There are one zero behind it. All the remaining ones are 1. So that is the only case you need to consider. And yeah, impossible is when, let's say it is like this. Ah, sorry. 1, 1, 1. Till the end, I'll only get a 0. If all of them are 0, it can also mean this, all zeros. It can also mean all ones. It can mean anything. I have no clue how to answer this. So that is why I print impossible. So those are the only cases. I'll go through the code only for you to understand. This is an interactive problem. There are some things to it, but A dot CPP. Yeah. So now interactive problem में wherever you are querying, when you're printing something, you need to do cout.flush. It is always mentioned in the question only. Like here it will be mentioned, but it's because some issue with garbage collection in C++. But yeah, so this is a query format. In any interactive problem, you just build these two questions so that it's these two functions so that's easier for you to code up. You don't need to always do this querying every single time. So what am I doing? I'm always querying 1 to R. I just need to query just R, right? This is the query format. I do cout.flush. I take an input and I return this answer. Now my word answer is basically like I've taken it as a vector char. You can take it as a string, but I just wanted to take it as a vector char because it's easier to initialize. That's it. And yeah, this is just my answer printing out. But what is my logic? I have done basically what I have told you in my logic. Okay. So firstly, I initialize the entire array as spaces and n plus 1 just because it's a one base indexing and I want to have it one base indexing. I just keep it as one base indexing. Just make a n plus 1 sized string or a vector, whatever you want. My previous is 0. I start with 2 because querying this and this is the same. While I'm always going to have a 0, so it just doesn't make sense to make querying 1 comma 1. So I start from querying 1 comma 2. I query 1 comma 2. If both of them are 0, I just continue. If value is not 0 but previous was 0, this is my first change. Since this is the first change, firstly I'll update the previous value. Now I firstly initialize my current index to 1. All the previous values till my value remains whatever, let's greater than 0. I'll assign it 0. All the other values I'll assign it as 1. And for all the other cases, if my value equals to previous, answer is 0, or else answer is 1. And I change my previous, that's it. And the only other case, if my previous is 1, after iterating overall, my previous is 1, previous is 0, that means it's impossible. I print that, and or else I just do answer. Any doubts?
Hello,
Yes, yes, bolo.
can you check my code? Like I'm getting a TLE on my code, not even a wrong answer.
Okay. TLE is crazy, but wait. Oh, time limit exceeded. Okay. Probably idleness limit exceeded, but let me just see once again. First, you're doing what? Okay, 1 to n, just okay, fair. Doesn't really matter, but yeah. You're doing I to n, you're doing reverse.
Yes,
Okay, fair, like works. Whatever suits is just perfect. And hi,
मतलब basically it gives one at the end. That pref is not equal to n minus I plus 1 always satisfies. So it always gives the answer, and the only case it gives impossible is the end.
Wait, I have a question. What happens to your code in this case? All zeros. It might give a TLE.
All zeros, initially the answer is zero, ना तो break statement है when
Break किधर है?
if curve is zero.
Where is
If
curve
curve
is
is zero then
zero?
break. हाँ, तो मैं हमेशा रिटर्न कर दे रहा हूँ, या तो आंसर देके या तो नहीं
I don't
देके.
know, but curve is zero
वही
is
इनपुट
like
लिया ना.
no, but let's say it was this. Okay, all zeros here. Okay. The issue with your code is, oh wait, I don't no. Okay, fair. Doesn't matter. Got it. Hmm.
Then also it should give a wrong answer. No? Why it is
This should give a
giving?
wrong answer because all of these can be zeros also. Firstly, but
No, no. Like if previous one was not zero and current one is zero, then आगे का all is one.
okay, no, not really. Just take this example only, no? पहले का one is what? One. इधर का is zero. Same thing, no?
हाँ.
Yes.
Then also I'm asking n questions. No, n minus one questions. Then also it's
No,
giving
no,
a TLE.
you're giving n minus one question. That is fine. Here you're not doing C out dot plus, sir. Here you're not doing C out dot plus.
नहीं,
C
solve
out
के
dot.
नीचे सी आउट डॉट फ्लैश किया है.
Array, don't do this. You have to do C out dot plus. Array, every single query, every single answer. Here you're querying, na?
हाँ, but I am doing सी आउट dot flash everywhere except when I'm giving an answer.
Mm, it's just bad practice to do this, but okay. Like I have no clue where it is. Like first, it should give wrong answer. That is so there only. But without wrong answer, just take the test case. No? 0, 1. You're just doing some weird thing which is causing it to give you TI. No clue. We'll have to just see the probably. Okay. So that is it. Any other doubts? I will close the stream.
Where to find the interactive problems?
What?
Where to find the interactive problems? Like, do you
Oh, okay.
have
Where to
any
find? Okay.
instruction?
Go to the problem set. Mm, yeah. Here you can add a tag and you just search interactive over here. Here you'll get all the interactive problems. And you just check their ratings. If you think you can solve it, let's say I want to solve only 800 to 1200. Okay, so I can add the difficulty tag also. I don't know how many interactive problems are this level. Only two. Fair enough. Okay. Usually interactive problems are of a higher rated because it is something which people are not used to. And secondly, they involve some kind of logic which people are not used to. That is the main thing. That is why they're high rated. Any other questions? I guess that is it. We can say bye bye to stream. Like, share, subscribe. See you in the next contest.